part called as potable water. This is in the GCSE paper number 2. Now, in the potable water, we have to understand that what exactly do we mean by the potable water, right? Potable water, in one definition, you can open up the book quickly. This might be page number 208 or 209, I guess. Please open the book quickly. Huh? Underline this part. Please mark it with a pencil, right? Isn't it? Mark it with a pencil, right? Water that is fit to drink is called as potable water. That's it, right? We don't have to exaggerate, right? Directly to the point, crispy to the point. Water that is fit to drink is called as potable water, right? Isn't it? Fine. That's the definition, right? Isn't it? Now, water is very vital, right? Water is very vital. Water is very useful for us, right? It is used in the agriculture, in the industry, in washing of our clothes, right? In our washrooms, we are using. But in this chapter, we are mainly focusing on what? Mainly focusing on the potable water, right? In the potable water, we have to understand that what exactly do we mean by the potable water by which we find it out. Now, there are two things which you have to understand, right? One is that we will be separating down the zone of the world into two parts, where it rains, where it does not rain, right? Fine. We have to extract that source of the potable water. Potable water is the water fit to drink. Okay, that's great. But it is source, right? We just source that water and clean it and make it fit to drink. There are two situations which will be giving in this chapter, right? One is the countries where abundant rain is there. One is which does not rain at all, right? So where countries where it rains abundantly, they're lucky people, right? Suppose in UK, right, it rains abundantly, right? So obviously, what happens when it rains? Now open your book and underline this aquifers, right? This part, right? When it rains, what happens? The rainwater falls to the ground, right? Rainwater falls to the ground and goes below the surface, right? Now over here, remember one thing. This bit I'm writing in red. There are many bacteria in the soil, right? Which also get soluble, right? In the water. By the water, it also carries the bacteria. Now, finally, this rainwater ends up into what? Spongy rocks, right? It's not a sponge, means you cannot press it, right? Means spongy means what? Spongy, it means fine hair are there, fine hair. This, right? Rocks, right? Water drops down from the soil and it goes and gets accumulated in the spongy rocks, right? Which are there, right? Isn't it? Right? Isn't it? Now, what we do? We drill a hole over here, right? We drill a pipe, right? And we get this. This is called as groundwater, right? We get it from groundwater, right? So potable water can be obtained from the groundwater where it rains. Now we are trying to focus upon the countries where it rains, right? So when the water drops in the soil, right, it also gets solubilized with many chemicals which are there, right? The calcium, the iron, right? These are also solubilized, right? And gases also gets also solubilized, and microorganism. This will be very crucial. This microorganism, right? Because finally, in the potable water state, you have to take out the microorganisms, right? The bacteria and the other microorganisms, right? By the ultraviolet ray, right? Or the chlorine. We'll be seeing this, right? Isn't it? Now, the different sources are what? The groundwater we are having. We are having lakes and rivers where it rains abundantly, right? Now, in this particular process, what we are doing in this process, we are mainly doing what? This is the first step. You open up your book and mark this one, right? We're accumulating the water in a reservoir, right? Then we do what? We pass this water through iron meshes, right? So that the large objects such as leaves and the twigs, that gets eliminated over here, right? Then it comes to the settlement tank. Write down two over here, right? In the settlement tank, the larger mud particles, they're allowed to settle, right? And this water is then taken out to the third tank, right? Which contains coagulating agents. You can write down coagulating agents. See, over here, the water contains fine particles which are suspended, right? Isn't it? Fine particles which are suspended. What science has done, thought of, that can we coagulate this all these fine particles into larger particles so that it can drop down and get settled? Yes, right? Do you get my point? Over here, we are having fine particles still left, which is hanging on, and it will be hanging on. But what we are adding aluminum sulfate and lime, right? Which are coagulating agent. They'll be clumping the smaller particles to larger particles, and these will be sinking down to the bottom, right? Isn't it over here, right? And form a mud, right? Next, we are taking this water to the fourth tank. This is the fourth tank. Water over here is passed through a sand filter, right? A sand compressed filter, right? A sand and gravel compressed filter, right? So now the all the final, the mud and the grit which is there over here is finally eliminated, right? The fifth part, water looks sparklingly clean, absolutely sparklingly clean. But see, I told you, when the rain falls, what happens? The bacteria and the microorganisms that also got dissolved. We have our task finally to eliminate the bacteria and the microorganisms finally over here, right? How do we do it? We do it via three ways. First is the cheapest way. The cheapest way is what? The cheapest way is that we add chlorine, right? Means all of you, you're going to a swimming club, you can smell fresh chlorine from there. Then how does chlorine smell like, right? We take chlorine and we do what? We kill the bacteria. Chlorine can be very lethal to human beings also. Chlorine is used as a chemical weapons in the warfares, right? That's banned by the UN, right? Isn't it? Second is what? We can also use ozone, right? Much more better form, right? Ozone. We can use ozone or any other costlier kind of killing the microorganisms is the ultraviolet light, right? So these are the three processes we kill the microorganisms, right? Now finally, the water will be coming and the pH of the water has to be tested. Mark it 6. Why the pH has to be tested? Because of the fact that we have to make sure that this is a potable water, right? This should be fit to drink. Our biological processes should not have any higher pHs or any lower pHs, right? That will be devastating from our biological processes. So the pH is checked and ultimately they are pumped into the schools and the colleges or the houses and the factories and the hospitals, right? So this was all about what? This was all about the process called as potable water. Now, finally, we are coming to the part of that where it does not rain, right? Does not rain, right? Such as those countries where bad luck, right? Suppose UAE, right? You have got Iran, Iraq, right? Syria, right? Where it does not rain at all, right? Gaza, right? You can say Israel, right? Yeah, it does not rain in UAE and all the Arab countries, right? So they have got what? They have got seawater, right? They have got seawater, right? To take out, right? Please open your book quickly. This is page number 209 or 210. Please open your book quickly. We do what? We take seawater. They take seawater. Seawater has got huge amount of sodium chloride, right? Mainly sodium chloride plus water, right? So we have to separate out this sodium chloride, isn't it? Isn't it? We have to separate out. In all the processes where we take seawater, we separate out sodium chloride, right? This process is called as desalination. You can underline this. This should have been here, huh? This should have been here. So the first process by which we separate out is desalination, right? Desalination process by which we convert salty water to potable water, right? Is it clear? Right? Desalination process, right? Now, in the desalination process, the first process we do is distillation. You can mark it 1. Distillation is an expensive process because it will be involving huge amount of energy cost, right? Isn't it? Large electricity is used, right? Now, mark it 2 over here. To lower down the temperature of boiling, right? Isn't it? The boiling point of water is 100 degrees centigrade, right? Can we do something where we reduce the temperature of boiling and save energy cost? Yes. That is done by a flash distillation. Please open your book, please. Flash distillation process. In the flash distillation process, we do what? We boil water by distillation under reduced pressure, right? If you lower the pressure, what happens? Water will be boiling below 100 degrees centigrade, right? Isn't it clear? Understood? And we save the cost of the electricity, right? Now, underline over here. Reverse osmosis, right? The third, right? All these processes are desalination process, right? Means the way by which we convert the salty water to a potable water. Reverse osmosis. In the reverse osmosis, we are doing what? We are taking membranes, right? Membranes. The membranes are very costly. The main cost is the membranes, right? We take membranes. The membranes will be having what the membranes will be having a particular spore size, right? Particular pore size, right? Which will be allowing water to pass through, right? And not other sodium chloride, right? What we do, we take water, seawater, and this uses much more less amount of energy than distillation, right? We pump water through water pipes, through a very very powerful pump, right? Isn't it? Now we get the 98%, all the dissolved solutes will be eliminated. But this saves energy, agreed. But this has got a negative point. What's the negative point it has? Can anybody tell me that? What is the disadvantage of reverse osmosis? Please go to your Zoom chat and send me, please.